Hello all, my name is Krishnayak and welcome to my YouTube channel. So guys, today in this particular video we are going to discuss about a library which is called as Keras tuner, and this will help us to decide the number of hidden layers and the number of neurons in each hidden layer in the neural network that we are actually designing that will be suitable for any kind of use cases that you are solving. This is specific to artificial neural network, so we'll try to solve a problem. I'll take a data set, I'll tell you about the data set, what that specific data set is all about, and then we'll try to decide that by seeing that particular data set, how many hidden layers we should select and how many number of neurons we should select in each and every hidden layer. Now, if you don't know about Keras tuner, guys, it is an amazing library which will actually help you to do that particular part, which is actually helping you to find out the number of hidden layers and neurons, right? So before going ahead with respect to this video, this is the documentation page. The link of this particular documentation will be given in the description of this particular video. If you really want to see it, you can actually see it, read everything about it, and there are other various techniques, and it is an amazing library which I have actually tried it out. I've been trying it out from long time and many people were actually asking this particular question, so I planned of creating this particular video. Now let's do one thing. First of all, to start with, I'm just going to go to my Anaconda prompt. In my Anaconda prompt, first of all, remember I will be activating my env environment. The reason why I'm activating, because over here the requirement that we basically have in Keras tuner is Python 3.6 and TensorFlow at least 2.0. I tried with Python 3.7 and it started working, guys. So this requirement need not be necessary, because I tried it out with 3.7 also, it is working absolutely fine. But at least it should be more than TensorFlow 2.0. okay, when you have TensorFlow more than 2.0, you also have Keras integrated within them. Okay, so to begin with, what I'm going to do, I'm just going to check what is my if I go and see what is my TensorFlow version. Okay, so I'll just write TensorFlow, import TensorFlow. You can see over here, right? I'll just press shift enter, and since I have a GPU, guys, over here, so you're getting this particular information saying that successfully opened dynamic library CUDA RT C4_1011 101.dll. okay, now what I'm going to do is that I'm just going to print, okay, TensorFlow dot underscore version underscore. So once I do this, you'll be able to see that I'm getting 2.2.0. So at least it should be greater than 2.0. Right now in my environment, I have created a new environment like my env. I hope you all know how to create an environment. I have already discussed so many number of times. So in this, you'll be able to see that I'm having TensorFlow 2.2.0. Now what I'm going to do, I'm just going to exit this. Okay. Now the first thing first is that I need to install Keras tuner. Now in order to install, let's go to the documentation page. It says pip install -u Keras -tuner. Remember, you can also write pip install Keras tuner, right? So once I execute this, please, and again guys, the TensorFlow should be greater than 2.0. okay, so here you will be able to see requirement is already satisfied because I've done the installation. Suppose if you're doing the installation, I've also heard that some people usually get environment issues, they may get this particular library issues. If you're getting that, try to create a new environment, try to do the installation. Other than that, even though if it is not working, just try to see your TensorFlow version. Then if you really just want to check, just try it in Google Colab also, that would also be good. Okay, so I have installed it, and based on this, I'll go and open my Jupyter notebook. So here is my Jupyter notebook. This is the whole problem statement. Now the first thing first, what we need to do is that I'm going to import pandas for reading the data set. I'm going to import Keras from the TensorFlow. I'm also going to import layers, and then I'm also going to import Keras tuner.tuners import random search. So this Keras tuner, right now we have it actually installed with the help of pip install Keras-tuner, and from that I'm going to install this particular library which is called as random search, because this is actually going to decide like how many number of hidden layers and how many number of neurons I have to use in each hidden layer. We just have to give the range, range of how many number of hidden layers is required, how many number of neurons is required. So let's see what is the problem statement all about. So I'm just going to execute this. This import is normal. I hope everybody's familiar with that. I'm going to import this real_combine.csv. All this particular information will be given in the GitHub. The link will be given in the description of this particular video. If I go and write df.head, now this particular problem statement is all about air quality index prediction. So I have all these particular features. and I'm going to predict the PM 2.5. This PM 2.5 will actually help us to determine what is the air quality index. So this in short is a regression problem. Again guys, after showing this, you can also solve a classification problem statement by using the same techniques. Only some parameters will be changing, like your loss function, your validation accuracy, what parameter you have to basically use for the validation accuracy and all. But since it is a regression problem, the parameters will completely change. So here is your data set, and we'll try to find out what is this PM 2.5, based on the values that we have over here. The features that you see over here are somewhat like this. May be the temperature, this may be the maximum temperature, this may be the minimum temperature, this is SLP, some more other different kind of parameters. Okay, and again, this data set also I'll try to give it in the GitHub link. The link is in the description. Now the next step is that what we'll do is that we'll try to divide this into independent and dependent features. Now as you all know, PM 2.5 is my dependent feature, remaining all are my independent feature. So that is why I am writing df.ilog : -1. So here I'll be getting all my independent features in my X and all my dependent feature in Y. So I'll try to execute this. Once I execute it over here guys, now this is the most important thing. Okay, this is the most important thing, and with the help of this particular thing, and this is actually all happening here. In short, if I'm just talking about this build_model is a function, is a custom function that we have defined, and this is doing something. It is just creating a sequential model, and it is using this for I in range hp.int. hp.int basically means this hp is nothing but the parameter that we are giving when we are running this random search. By default, it is basically assigning this specific, it is assigning the instance of that specific model that we are creating. So inside this, what is happening? See, for I in range hp.int number_layers, num_layers. So this is just a name. I am saying that what I will do is that I'll just try to do something. Okay, I will try to create a neural network. In that particular neural network, the first range that I'm giving, I'm saying that the neural network can have layers between 2 to 20. These all layers are nothing but hidden layers. Okay, between 2 to 20, like it may have 2 layers, it may have 3 layers, it may have 4 layers, but it will be less than 20. Okay, so 2 to 20 layers it can have. Okay, and then once I go inside this after inside this for loop, I'm saying that inside each layer I can use a dense function. Dense function is basically used to create nodes, neurons, right? And inside that, the number of neurons that can be present will be ranging between 32 to 512. Again, you can change this particular parameter, guys. You can change this particular parameter. Okay, it can be 32. The minimum value will be, that basically means the number of neurons that will be ranging between 32 to 512. You can again make it 1024, you can make it 1000, 2000, 3000. But what I'm saying that minimum at least you should have 32 neurons, and then the maximum number of neurons that should be there in each and every layer can be ranging between 32 to 512. That is what this whole values is basically specified, right? And then you'll be able to see that, and this is happening in each and every layer. So if I'm considering 2 to 20, right? So the two layer basically means hidden layer 1, hidden layer 2. If I take 3, the next parameter is basically 3, since I'm running a for loop, right? In that case, I will be having 3 layers. And again, the minimum number of neurons will be 32. The maximum number of neurons will be 512. So we have to do a random search within them, try to find out what will be the best possible neural network that we will be creating. And here you can see that we are trying to apply a activation function, that is ReLU. Okay, in each and every hidden layer, obviously ReLU performs well. So we are basically applying ReLU activation function. You can also apply other activation function like pre-ReLU and all. But here I'm just trying to apply ReLU because ReLU works very, very well with respect to all the hidden layers. Okay, now fine. This is with respect to the hidden layers. Now hidden layers here, all the possible values that we have defined it over here. And it can have hidden layers between 2 to 20. Okay, that also we have actually defined. Out of all these particular layers only, the random search, this particular library will be selecting the best number of hidden layers and all, right? I'll show you that, just wait in some time. Okay, then finally I will be adding one output layer which is called as a dense layer. Again, the number of output neurons will be only 1 because this is a regression problem statement. And inside this, usually for regression problem statement, we use an activation function that is called as linear. Okay, pretty much simple. Then we are doing model.compile. Here the optimizer that I'm taking is Adam. Again, here the learning rate is again kind of a hyperparameter. Okay, and here you can see that the values like 0.0001, 0.0001, 0.0001, right? So this 3 learning rate, I have given the parameters. Again, the random search will be selecting out of this, right? And then I have my loss function as mean absolute error, which is basically for the regression problem statement, and you have something called as metrics. So this whole function is basically creating a model. Now, one thing that you need to note over here, what are the hyperparameters? What are the hyperparameters? If I discuss about this, what are the hyperparameters when we are creating this neural network? First is nothing but how many number of hidden layers we should have. How many number of hidden layers we should have, right? So this is the first question. The second question is that how many number of neurons we should have in hidden layers. So this is my second question, right? This is my second question. These are all kind of hyperparameters, right? The third thing is that what should be the learning rate? And here also I can give multiple learning rate parameters. So here within this, whatever I'm creating in this build model, I'm giving this 3 parameters as my, the parameters with respect to the hyperparameters over here, which will be changing. And out of all these things, I've given options for number of hidden layers. Here you can see the number of hidden layers, like it can be between 2 to 20. So I'm running a for loop, and this many number of hidden layers will get added inside this. Then the number of neurons is basically being given between 32 to 512. Out of that, we'll be selecting one, based on each and every hidden layer, whichever is performing well. Finally, my output layer is basically we are creating another dense layer. In that, only one output node, because this is a regression problem statement. Only one output I'll be getting. The kind of activation function I'm using is linear. Then I'm doing the compile. I'm using the Adam optimizer. Okay, and inside this I'm using hp.choice. You have two functions, either hp.int or hp.choice, right? Over here, choice basically means out of this 3 options I can select one. hp.int basically means that I will try to try with different values itself over here. But in case of learning rate, I will be choosing either one of this. Okay, then the loss function that I'm going to use is mean absolute error. The metrics that I'm going to use is mean absolute error. So once I execute this, okay, and this is the function of definition build model. So as soon as I call this build model, so here you can see inside my random search, this random search is nothing but I have imported from Keras tuner, and inside this you'll be able to see that my first parameter is build model. Then objective basically means that whenever we are training the model, inside that, here one parameter that you will be getting is val underscore mean underscore absolute error. Okay, so this particular parameter you will be getting, I'll show it to you once I'm training it. But this objective may change for a classification problem. How do I find out this particular objective? I'll just tell you. Okay, the maximum number of trials that I'm going to do 5, execution per trial will be 3. So that basically means that suppose for this one type that has been initialized and selected, we'll be trying to run 5 into 3, 15 different iterations, and we'll try to see whether it is working fine or not. What will be the value, accuracy or mean absolute error? I'll not say accuracy because this is a regression problem. What will be the mean absolute error with respect to that? And remember guys, here I'm going to create a directory. This will make sure that all the weights are getting stored inside this particular directory as the training is actually happening, as the search is actually happening. Okay, so here these are all the parameters with respect to random search. More information is basically given in this Keras tuner. You can check it out. Each and every parameters, what exactly it is, what is this execution per trial. Just understand this max trials is basically 5, execution per trial. How many times inside one trial, inside one iteration, how many times you have to run with respect to all these particular parameters. So in total it will be running 5 into 3 times, that is 15 times. So once I execute this, so my tuner is ready over here. Then I can also execute this tuner.search underscore space underscore summary. It will say that what all searches we are actually doing. This is the search space summary. You can see the default search space size is 4, max value is 20 with respect to the number of layers. Then you have with respect to first hidden layer, max value is 512, min is 32. Like that, all this particular information is actually present. Like even learning rate is a choice parameter, and all this information is present. Default is this much, values is this much, right? Different values. All the information are clearly present over here. The next step that I'm going to do a simple train test split on x and y, because x and y is basically having my independent and dependent feature, because obviously I require this because I'll be able to check my validation data set. Once I do this train test split, all I have to do is I just have to write tuner.search. Tuner is nothing but it is a random search object, okay? And then I will be giving my x train, y train. I'll be saying that run it for 5 epochs. The validation data I'll be giving as x test and y test. So as soon as I execute this, guys, you'll be able to see that how quickly each and every you can see that, right? This is my validation loss. This is my validation mean absolute error. And this parameter only I've given it over here. See, guys, val underscore mean underscore absolute error, I've given it over here, right? The same thing. This is basically my objective. In case of classification problem, it will be accuracy, okay? Validation underscore accuracy, or val underscore accuracy will be there, okay, in case of classification problem. But in case of regression, since I've used the optimization function as, not optimization function, I've used the loss function as mean absolute error, so the metric will also be like that, okay? So here you'll be able to see that is why I've written val underscore mean underscore absolute error. This will basically be my if I go over in here in the top, you will be able to see that will be my objective, and that only we have to basically write. That is what this random search actually says. Now probably this whole training has done, guys. Let's see, let's go down. Now here you can see that this all training has happened. You can check it out that how your validation loss is decreasing. You will be able to see your validation loss is decreasing as the different iteration is happening. Again, sometimes we have to increase this number of epochs, you know. We have to at least keep it for 100, 200. Now just to show you an example, I've kept it as 5, you know. Sometimes if you have to keep it as 100, and probably it will not take much time to run. If it is taking time, just try to run it in Google Colab. Now don't worry about this, just check that whether the validation loss is decreasing or not in each and every iterations or each and every epochs that you see over here, and then go to the next thing. And here, after completing all the iterations, you'll be able to see results underscore summary. Now in results underscore summary, if you go on the top, okay, it will give you the best 10 best trials, okay, with the objective name as val underscore mean underscore absolute error, and direction is towards minimizing it. So this is my first trial. In the first trial, we got the score as 47.77, and remember, this is the mean absolute error. And always remember that the error should be less. Okay. So we have hyperparameter over here. What are the hyperparameters that got selected? With respect to learning rate, it got selected as 0.01. The number of layers that got selected is 10. I gave between 0 to 20, right? And by doing all the search, 2 to 20, by doing all the search, it has found out that for the best choice that we have, we can have number of layers as 10. In the first layer, we'll be having 192 neurons. In the second layer, we'll be having 256 neurons. In the third layer, we'll be having 32, 32, 30. In the fourth layer, in the fifth layer, I'll be having 32. Sixth layer, 32. Again 32, 32, 32, and finally I'll be having the output after this, right? The second trial basically shows that the score is around 58.95, which is not better than this, okay, which is not definitely better than this, because here my score was 47.77. In case of mean absolute error, this should be nearer to 0, okay? Just think in that specific way. Number of layers is 15, you can see all these values. Number of layers is 11, you can see all these values, number of layers. So like this, you can see that whichever is performing the best. Now in this particular term, you will be seeing that whichever is performing the best, you can select that, and you can create a 10-layer neural network and make sure that you provide all these particular parameters with respect to this, like in which respect to each and every layer, this many number of neurons you can actually select, okay? So this is actually giving you a lot more easiness to actually select the number of hidden layers and hidden neurons. So I hope you like this particular video. Again, all these particular materials will be given in the GitHub link provided in the description. So yes, I'll see you all in the next video. Have a great day ahead. Please just try it, all these things, try regression, try classification problem statement by your own, and let me know like whether you like this particular tutorial or not. So yes, I'll see you all in the next video. Have a great day ahead. Thank you and all. Bye bye.